One of the areas of current technology that is undergoing the most rapid advancement and transformation is artificial intelligence. AI has evolved through several phases, each of which represents a major advancement in capabilities, techniques, and societal ramifications. These stages range from the technology's conceptual beginnings to its current state of sophisticated applications. Knowing these phases offers a way to not only understand the evolution of AI, but also to predict its future paths and its effects on different facets of human existence. The history of artificial intelligence. AI started with symbolic AI, when early adopters tried to mimic human intellect using rule-based systems. Although this era faced challenges in managing complexity and ambiguity, it also set the groundwork for robots to reason logically and solve problems. The rise of connectionism, which followed symbolic AI, brought neural network-based techniques motivated by the architecture of the human brain. The transition to learning from data ushered in a new era of achievements in cognitive modeling and pattern recognition. Algorithms' capacity to learn from experience and enhance performance led to the rise of machine learning as the predominant AI paradigm, revolutionizing a number of industries through applications in data analysis, prediction, and decision-making. AI skills were further enhanced with the introduction of deep learning, which allowed computers to process enormous volumes of data and perform jobs like speech and image recognition with previously unheard-of precision. Beyond technological breakthroughs, ethical issues have gained prominence recently, sparking conversations and actions meant to guarantee the proper development and application of AI technologies. Once again, welcome to another thrilling video. The topic of today's video is the 7 stages of AI. Please hit the bell icon, subscribe, and like the video before we begin. Number 7. Symbolic AI. Symbolic AI, also known as good old-fashioned AI, GOFAI, was the pioneering approach in artificial intelligence, established in the mid-20th century. The technology was grounded in the manipulation of symbols and logic-based reasoning, focusing on clearly defined rules and algorithms. AI systems at this stage didn't learn from data like modern AI systems do. Instead, they operated strictly by following predefined rules created by human programmers. Expert systems, for instance, were an early practical application of symbolic AI, used to solve complex problems in specific domains, such as medical diagnosis or financial planning, by applying a set of predefined rules. Though effective for certain tasks, symbolic AI struggled with the ambiguity and uncertainty found in real-world scenarios, which eventually led to the search for more flexible approaches. Number 6. Connectionism. Connectionism, emerging in the latter half of the 20th century, marked a significant paradigm shift in AI development. Drawing inspiration from the structure and functioning of the human brain, connectionism introduced artificial neural networks that could simulate the learning process. Unlike symbolic AI, connectionist systems were not hard-coded with explicit rules, but could learn from data, adjusting their internal parameters based on the input they received. This development paved the way for machine learning, allowing systems to recognize patterns, perform speech recognition, and engage in adaptive behavior. For example, neural networks could be trained on vast datasets to identify images or understand spoken language. Connectionism laid the foundation for the rise of machine learning, marking the transition from rigid, rule-based systems to more flexible, data-driven approaches. Number 5. Machine learning. Building upon the concepts of connectionism, machine learning became the dominant approach in artificial intelligence. Machine learning techniques enabled computers to identify patterns, make decisions, and generate insights from large datasets without explicit programming for every task. 3 primary types of learning, supervised, unsupervised, and reinforcement learning, became central to the field. Supervised learning, for example, trains models on labeled data to make predictions, while unsupervised learning seeks to uncover hidden structures within unlabeled data. Reinforcement learning, on the other hand, allows systems to learn by interacting with environments and receiving feedback. These capabilities have revolutionized industries like healthcare, where AI can assist in diagnosing diseases from medical scans, and in finance, where algorithms predict market trends. As machine learning matured, it fueled innovations such as self-driving cars, fraud detection systems, and highly personalized marketing strategies. Number 4. Deep learning. Deep learning, a subfield of machine learning, focuses on artificial neural networks with many layers, hence the term deep. These deep neural networks are designed to automatically discover representations from data, allowing for more advanced pattern recognition and decision-making capabilities. Advances in computing power, particularly through GPUs, and the availability of vast amounts of data have propelled deep learning to the forefront of AI. Unlike traditional machine learning, which often requires manual feature extraction, deep learning can automatically learn to extract features, making it especially effective for complex tasks like image and voice recognition. Convolutional neural networks, CNNs, have been particularly successful in image classification, while recurrent neural networks, RNNs, excel in tasks involving sequential data such as language translation and speech recognition. Today, deep learning is integral to technologies like virtual assistants, autonomous vehicles, and recommendation engines. Number 3. Artificial General Intelligence, AGI. Artificial General Intelligence, AGI, represents the next frontier in AI research, aiming to create machines that possess human-like cognitive abilities. Unlike narrow AI, which is designed for specific tasks, AGI would be capable of performing a wide range of tasks, learning and adapting across different domains. The pursuit of AGI involves breakthroughs in areas such as transfer learning, which allows systems to apply knowledge gained in one area to another, and meta-learning, where machines learn how to learn. Cognitive architectures that attempt to mimic the human brain's general problem-solving strategies are also being developed. While AGI remains largely theoretical at this stage, the potential impact is vast, ranging from fully autonomous decision-making systems to machines capable of reasoning and understanding complex, abstract concepts. However, ethical concerns about control, safety, and unintended consequences remain key challenges for AGI researchers. Number 2. Artificial Superintelligence, ASI. Artificial Superintelligence, ASI, refers to the hypothetical stage at which AI surpasses human intelligence across all domains. While AGI aims for human-level cognition, ASI would exceed human intellectual capacities by orders of magnitude. ASI could potentially develop innovations beyond human comprehension, solve complex global challenges, and even redefine the trajectory of humanity. The idea of ASI raises deep philosophical and existential questions about the future of human civilization. For example, if a superintelligent AI develops goals that are misaligned with human values, it could pose existential risks. These concerns have led to increasing calls for responsible AI research, ethical frameworks, and governance systems to ensure that ASI, if ever achieved, benefits society rather than harms it. The potential impact of ASI could range from scientific breakthroughs to unprecedented social, economic, and political disruptions. Number 1. Singularity. The concept of the singularity refers to a hypothetical point in the future where technological growth, particularly in artificial intelligence, becomes so rapid that it leads to unforeseeable and irreversible changes in human civilization. At this stage, AI would advance at an exponential rate, creating new technologies and systems that surpass human control and understanding. Some futurists predict that the singularity could bring about unprecedented levels of innovation, unlocking the full potential of intelligence across the universe. Others, however, caution that such an event could also lead to catastrophic outcomes, including the loss of human agency or existential threats posed by autonomous superintelligent systems. As a result, discussions around the singularity often emphasize the need for rigorous ethical considerations, global cooperation, and careful planning to mitigate the risks of unrestrained AI development. There are discrete stages in the growth of AI, and each is distinguished by notable breakthroughs and paradigm changes. AI has changed dramatically throughout the years, from the early rule-based systems of symbolic AI to the sci-fi worlds of artificial superintelligence and singularity. Gaining knowledge of the 7 phases of AI development will help you anticipate future possibilities and problems. We appreciate you viewing the video. Please remember to like and subscribe to our channel in order to see more thrilling videos like this one.